builds, tests, or deployments. So by this way, we can improve the efficiency. Then the next thing will be the CI/CD. We have heard it all the time, CI/CD pipelining. So it is nothing but continuous integration and delivery. That is continuous integration, continuous delivery, CI/CD. So here, regularly integrating the code changes and deploying those codes into production with the minimal human intervention or manual intervention, we can say. So at this point of time, our CI/CD pipeline will be very helpful. So that is also given by DevOps. Hence, DevOps will promote the CI/CD pipelining, that is continuous integration and continuous delivery. Right. So then the last one will be the monitoring and feedback, that is constantly monitoring the performance and behavior of the application in the production. Yes. So these are the things that DevOps will promote, and DevOps is also used for whatever I have told: efficiency, scalability, quality, and speed and agility. Right. So let us move on to now what are the build tools. We always hear there are some build tools that we use in DevOps, right? Build tools, it is a process of preparing the source code, they say, for production so that users can interact with it, right? So process of preparing a source code, we require a source code to complete any task. So the build tool will help us in preparing the source code. So it can include any compressions, that is file compressions or compilations, etc. So whenever we come across a term called as build automation, so automation is nothing but it will handle builds within the CI/CD pipeline, right? So this goes on with these several steps, so that those steps I'll be explaining you in the later part, so that I have taken it as a separate topic. So you can see initially whoever is the developer will commit the source code to a repository. So whatever repositories we have considered, so it will commit there. So the developer will commit the source code to that repository, and then a CI server, whatever CI, that is continuous integration server, will detect those changes. See, there are two types of changes that we can expect. One is entirely new source code that has been added to the repository, or a part of code that will be put into that, so that we required some changes and we are giving an update to it. So then that CI server will detect those change and it will run that particular build process outside the developer's ID. So developer has already put his code into the repository. So then it will check its unit test and it will run for the fixes. Or if it has to not run for the fixes, it will further move down to the pipe. Uh, Sony ma'am, can you please mute? Yeah, yes, thank you. Yeah. So this is the thing that happens. A developer will commit the source code to, what is committing? Committing is nothing but you're pushing it into the repository. Then a CI server will detect that change and the runs will be built outside the developer's IDE. If there is any unit testing to be done or fixes to be given, it will be checked or it will be passed down further for in the pipeline, that is CI/CD pipeline. Then the automation will also helps us to standardize builds, that is to make them faster and awkward. See, usually if humans are doing it manually, then there will be some mistake that might happen. So to ignore that, this automation will help us to standardize the build. So this is what is the build tools, and what type of build tools we are going to use, I'll be telling this in the later steps. So now when I told these steps, the developer will be committing the code into the repositories and how it will be running through the pipeline, there are certain steps here. You can see the first step is developer commits the code to the repository. So what is the meaning of this? The commit is nothing but it's the control system, it's the version of control system which are services that helps us to manage or update to the software, right? So example, we can take it as Git. So a developer is pushing his code into the Git, right? A code commit operation will also mean that an engineer sends the new code to the repository residing in one of those. So that is what I have told, an entire code can be changed or a part of code can be changed. Even then the CI server will detect the changes. Then the second step is that the CI server will detect the change inside the repository. So a CI server is a system, right, that orchestrates the CI pipeline. So, and it will also allow teams to commit the code multiple times. It's not like once you have committed the code and it is done. Multiple times you can commit the code per day, right? And build automatically outside of the developer's ID. So on the different target servers, we can say, if in the simple term. So a CI server will regularly poll the repository to check for the new commits and save the changes in the database. So these works will be done by CI server. Then the third point is build configuration recognizes the changes and triggers build agent. So when I say build configuration recognizes the changes, it is, what is a build configuration? It is the set of rules that will determine how the build is supposed to happen, right? So we can also say it as, or define it as, which operations and which tools we need to complete to build that task, right? If you want certain tasks to be done, what tools we require and how to build it, and what are the operations that has to follow. So that will be nothing but a build configuration, right? I hope you are with me here. So moving on to the next point, build agent activates build tools, right? So what is a build agent? Build agent is a program, right? It is deployed on the build servers that takes order from the CI server, right? It will be on the server that takes order from the continuous integration server and starts the build, right? So whatever changes was made, right, those things will be taken through from the CI server and the build will start. So it just, in simple words, if I want to say, it just listens to what a server with its configuration has to say, right? And orders the build tools accordingly to do their job in a way developer has configured. All these works will be configured by developers initially and it will do as it is, right? So fifth point, when we come to fifth point, we have build tools, then compiles, compress, runs, test, and etc., right? So build tool is a script or framework that I have told you, or a software that creates, that is created for particularly for a programming language to compile the code and run test on it, right? So if I say build tool, build tool is nothing but, we can say, a Maven or Gradle, we can consider that as our build tool. So these are popular build tools that are especially used for Java compilations and unit testing. So these are the things. Then if we go at the point, last one, build artifacts are sent back to the servers. Whatever artifacts are built, so the code passes all the build stages, say including the testing, right? It will normally be sent back to the CI server. When all the works are done, it has to be sent back to the CI server. At this point, it can go to the production or further testing or storage. So that is why they say build artifacts are sent back to the server. So for whatever reasons we require the server, it can be done either for productions or for the testing or storage, right? So then moving on to the full versus incremental build. There are two types of builds that we can use. One is full and another one is incremental build. So in full builds, we can say all the files that are taken, right, it will be rebuilt from the scratch. So that means that whatever files you have written, entire thing will be rebuilt from the scratch, right? Usually these builds are less common and it will take more time. That is why we do not use this. But in worst case, if we want to rebuild entire thing from the scratch, right, so at that point of time we will be using the full or clean builds, right? But we are mostly using incremental builds, which says that it will take less than 10 minutes as we don't build the entire code, right? So only some code changes that we put on to the repositories, right, only those builds will be considered. That is why incremental builds is used mostly, right? And only that part of source code that whatever developer has changed and he has put that, those codes will be considered. So that is why incremental builds are better in place of full builds. So now what happens is that if we have done a minor changes or some part of code has been changed, we can use incremental. But if you are changing almost all the source codes, right, so at that point of time we require a full or clean build, we can say. Okay, so then uh, build automation. So what is a build automation? As I've told you, it is the process of automating the tasks, right? So automating the, why do we need to automate the task? To execute and test the programs, right? So there are, they have mentioned there are different types of automations that can be implemented at various stages. So if we have to see some of the important automations that we use, I have stated it there. It is an infrastructure as a code. We say it as IAC, configuration management. Then we have CI/CD, continuous integration and continuous delivery, and we have continuous monitoring. So whenever we go to infrastructure as a code, right, we see what is exactly infrastructure as code. This we have seen it in the cloud itself, right? So in the cloud there is something called as IaaC. So we say it as a process of automating the infrastructure. So we automate the entire infrastructure so that developers need not manage the servers or the storage wherever they want to deploy. So what happens is that if the developers have written some source code, right, they don't have to also manage the servers, that what is going on within the server, or they don't have to look up to the storage that whether the storage is available or no, and only then they can deploy it. No, they don't have to do that. That will be done by infrastructure as code, right? So whenever they want, they can deploy the application and everything will be managed by infrastructure as code. So it enables the repeatable infrastructure deployment, like which minimizes disruptions when deploying the code. So like if there are some disruptions that is happening within the code, if repeatable infrastructures are there, right, at that point of time it can be removed out. So it also allows the team to control the complex infrastructures more easily, and it will also integrate into the SDLC lifecycle, that is software lifecycle management, right? So for this we will be using Terraform, Ansible, right? So in VTU syllabus we are using Ansible for that. So infrastructure as a code, we can use Ansible, right? So moving on to the second point, configuration management. How configuration management is done? So we know configuration management, I've told you, automating the configuration task, like how do we maintain the systems, servers, right, which reduces the manual errors in the whatever cases we find, or IT cases we can say. It ensures the consistencies across environments. So whatever consistency we require across environments, it will be taken care by configuration management. Even for this we are using Ansible. There is also a program for this configuration management using Ansible in VTU syllabus, right? We will be looking on to that. Then we have a continuous integration and continuous delivery. We have seen CI/CD. I have told you it will automate the deployment of the code, and that will speed up the delivery of the software application and reduces the integration errors. Whatever errors we are going to find, it will be reduced. So for this, we will be using Jenkins, or we can also take GitLab CI/CD pipeline. But here we have a fourth program in which we have to show the continuous integration and delivery using Jenkins. So we will be going with Jenkins. Going on to continuous monitoring. So continuous monitoring is nothing but it will automate the tracking of the system applications, which is which will be majorly done by release managers, right? So that can be tracked, and it identifies the bugs. So whatever bugs or we have, it will find it in the early troubles, we can say, so that it should not affect the users. So here we will be using Grafana, Prometheus, or Datadog. These things can be used. Continuous monitoring is not mentioned in the VTU syllabus, but for that we can use Grafana or Prometheus. We can show students how Grafana is used for continuous monitoring, right? So then moving on to the program one. So this is the first program of BCSL 657D DevOps. So the question is introduction to Maven and Gradle, overview of build automation tools, key differences between Maven and Gradle, and installation and setup. So when this question is asked in the VTU, students are instructed to write about the Maven, Gradle, the differences between Maven and Gradle, and what do they know about the build automation tools, right? And also there is a program wherein we talk about how the installation and setup is done. So let us see first the build tool that we are using. The first tool is Maven. So Maven is a build automation tool primarily used for Java based project. So I've told you Maven and Gradle both are the automation tool that is used for Java based project. So in Maven, this will simplify the build process, including all the source codes that we are using, testing, packaging, and deployment. So this is about the Maven. It is a build automation tool primarily used for Java based programs. So Maven will have a POM file, so which uses a project object model. So this is nothing but a pom.xml file. I can show you what this pom.xml file consists of while I'm coding for that. So it will describe the project's configuration. So what project is using, what are the resources it is using, and what code is there in that. So entire thing along with the IDs, group ID, artifact ID we call it. So everything will be listed in this POM file. So if we want to know about any of the project that we have implemented, we can directly go to this project object model and check what are the things here. It also contains the dependency management data also. So there is a dependency folder in which all the dependencies will be listed, right? So this is about the Maven. Now you can see, as I've told you, I've put a snip of the Maven project structure. So there is a project root. So whatever project is, then you can see a source, right? So within that you have main Java com example and whatever is the application name, that is my app.java, I can say. So here you can see the source followed by main and Java. So within the Java, right, there will be a source code. So it contains the main Java source code within that. Okay. If you see in the resources, right, resources will contain a non-Java source code, non-Java resources we can say, that is used by the applications, right? So it can be any of the files, right? Then if we come back to the web app, right, so the web app will contain the web applications that we have developed. So what resources were used for the web application? So all those things will be found in the web app, right? Then if you come to the test Java, right? So within the test Java, it will contain the test source code that we have used, right? And then within the resources for that test resources, so if I go through source, test and resources, right, I will get the resources that is used for testing. All that will be mentioned there. And then comes the target. So target will contain the compile classes. So compile classes are nothing but the packaged jar files and other artifacts that we have built, right? All those will be stored in the target. And then the pom.xml file, that is very important file of any of these Maven code. So this will contain, or this will define, we can say, the project configurations and the dependencies it has. It will also have some of the build settings that we are using, right? So all these things will be within the project object model, that is a POM file, right? So then moving on to, I told you Gradle is also one of the build tool that is used. So if you see, it is similar to that of the Maven, but has a greater advantage than Maven. So Gradle is an open source build automation tool that is used to manage, compile, test, package and deploy the software project. So again, it works same as that of the Maven, but the only thing is that it combines the flexibility of Apache Ant with dependency management capabilities of Apache Maven. So if you see in Maven, right, we will be using Apache Maven, particularly used for dependency management. Here there will be combination of Apache Ant and Apache Maven, right? So here it will support more multiple languages. In Maven, it will only support the Java languages. Gradle, if you come back, it will support multiple languages such as Java, Groovy, Kotlin. Actually, you can also select in Gradle through what you want to code. Like you want to go with Groovy as a domain specific language, or Kotlin or Scala or Java. So these are the options that the Gradle gives us. Now, if I have to talk about the features of the Gradle, obviously there is a dependency management, very good dependency management that will automatically resolve the dependencies from the Maven or other repository. So whatever, though we are using Gradle or Maven, we have a repository called as Maven Central, which will be used for both of this. So if we want any of the data from those repositories, we can pull it from the Maven Central, right? So then it will also support the IDE, right? It will work seamlessly with the popular IDEs, like you can use Eclipse, because we have used Eclipse, NetBeans for Java, right? So it will support, the Gradle will support these IDEs. And then we have incremental builds here. So it will only recompile the changed parts. If I have to say in the simple words, it will recompile the changed parts of the project. So what will happen? In this way, our build speed will be improved, right? Then when we go on to the build caching also, there is a term called as build caching. So it reuses the outputs from the previous builds. Like whenever you build any program in DevOps or any language, if you take, right, the build time that is required will be slightly high if the application is big, right? So at that point of time, this build caching will help us. So what it will do is, whatever already we have the previous build outputs that we have that will be reused if that part of source code has not been changed. Okay, so for build caching also the Gradle will allow, so that is one of the feature. And then the continuous integration, it is very friendly continuous integration, so easily for integrating with CI/CD tools like Jenkins, right? It is very easier for us to use it with the Gradle, right? Hence mostly Gradle will be preferred, but in the VTU syllabus we have both Maven and Gradle, right? Then moving on to the differences between Maven and Gradle, right? So what are the major differences? So if we see Gradle, it is based on the, I told you, domain specific languages such as Groovy and Kotlin, right? But Maven is based on developing pure Java language based. That is what is the first difference that we see in Gradle and Maven. Then for the configuration, right? Again, the Gradle will use the DSL, that is domain-based specific languages such as Groovy, and the Maven will use XML, that is the POM file, pom.xml, right? Project object model that will be used by Maven. That is the another difference we can say. The third difference is particularly focusing on to the Gradle will focus on to developing applications by adding new features to them, right? But in the Maven, if you see, developing applications in the given time limit. So within the given time limit, the applications will be developed. That is the main focus of Gradle and Maven. Then the fourth one is the performance. So it performs better than Maven as it is optimized for tracking only current running tasks. For Gradle, I said you, whatever current running tasks are there, or whatever code changes are there, that will be looked into more. So the performance is better with Gradle. And in Maven, if you see, right, it does not create the local files or temporary files during software creation. Hence, we do not even get build caching in Maven, right? So this is another difference. And if we go with Java compilation, we have to compile with the Java in Maven, and in Gradle, we can avoid the compilation. These are the major differences to be seen with Maven and Gradle. So let us look at the programming part. So if I look at the programming part, the first program for VTU syllabus was to install JDK, to install Maven, and to install Gradle, right? So I have, we will be forwarding you all the installation steps in the yes, we will be forwarding all the installation steps for your reference. So if we see here, wget will be used to install. So here there are some binaries. So the version of the binaries matters here. So this is the, as of now we are using these binaries, that is JDK 17.0.1. So this can be used for installing the JDK. So JDK installation we have seen, any, if you want to run the Eclipse also the same steps has to be followed. So we will be sharing these steps. Then after installing, you have to create a local folder. One folder you can create using mkdir in Ubuntu. Then you can extract the files that has been downloaded. So for that we will be using tar as our this, followed by whatever we have installed, that is there in the first line wget, the same thing we will be copying it along with the which folder we are going to dump it in, that is the local folder. So once that is done, right, we will get the JDK installation, that is we will be going on with nano bash rc. So why do we use this nano bash rc? To set the environmental path, right? So environment path are there, 3 lines are there, we have to paste it in this file, that is bash rc, and then we can go on with committing that. So for committing, we need source bash rc. So once that is done, you can check the Java version. So that will be say version, which version we have installed. So I've told you I have installed 17.0.1. So this version will be used. Okay. So this is the simple step that we can use for JDK. Then moving on to Maven installation. So for Maven, you can take, so when you install it, right, it will look something like this. So see, uh, oh. So I think you are able to see here, the OpenJDK 17U has been installed, right? The next thing is we have to install our Apache Maven and Gradle. So I have previously installed it and kept so that it takes a bit longer time. Okay, we need internet access and it will take some 15 to 20 minutes to install. That is why these things have been installed already, and I'm just showing you what were the steps that I have followed, right? Now, if you see here, we have taken again wget. So when you go to this downloads.apache.org, right, you will find some of the versions in that. So usually we used to use 3.9.5 previously. As of now, 3.9.12 is available. So that only that one I have downloaded. So the next step will be to extract the files present in that. So I'll be using tar, right, along with the what version I want, Apache Maven 3.9.12. Then the third step will be you have to move that Apache Maven file to the Maven file. So I have created a Maven folder. That is why I'm moving the Apache 3.9.12, whatever has been extracted, to the Maven folder that I have created. And then I will use echo to export the path. So the path I have set there. So this path remains same for everyone, and I will use the bash rc. So once this is done, right, I'm just setting the path here, echo. With echo, I'm setting the path, and then once I do source bash rc, that means that I'm committing the changes. Once the source is done, that is the changes have been committed, we can check with mvn followed by hyphen version. So we will get to know what Maven, Apache Maven we have installed, or whether it has been installed properly or not. Simple 4 steps are there, you can follow that. So here for me, the Maven home has been installed in home student Maven. This is the path in which the Maven has been installed. So if I have to show you, see, this is the Apache Maven 3.9.12 that has been installed for me, right? So you can see here I have created the folder and I had just put it in the bin, right? So yes, so this is how we installed the Apache Maven. So this is the part of our first program in which we will be installing both JDK for Maven and then Gradle, right? So the next one is how to install Gradle. The same thing, wget with the Gradle. So you can take any version. So it is 8.4. So once that is done, again extract the file. That is, extracting is unzip Gradle followed by the version of it. So once I do that, you can come to move. So again, I have created a Gradle folder, and Gradle 8.4, I'm moving it into that, and I'm giving the path to that, that is echo export path. So once that path has been put, I will just commit it by typing source bash rc. Then if I have to check the version of it, right, I will put Gradle followed by -v. So you can see the Gradle has been installed. Welcome to Gradle 8.4, and they have given the highlights of what we can use. Okay, so this 8.4, what build time it has taken, and the revision, or what the Kotlin or Groovy's version, everything, Ant version will be mentioned here. So if this line comes, then you can say that Gradle has been installed successfully. So this is how installation is done. We should make sure that after installing JDK, we have to move with
Mahesh,
and then Gradle, right? These are the only differences. So once this is done, so we can look into the program, right? So let me just open the program. Please give me a minute. I'm just trying to open the program. Yes, I hope you're able to see the, yes. So now, before starting with the program, let me just repeat the question of what we are going to do here. In the experiment one, they have mentioned for the introduction to Maven and Gradle, we have seen it. We have seen the overview of build automation tools and the key differences between Maven and Gradle, and we have seen the installation step. So this becomes the first program of the VTU prescribed syllabus. Moving on to the second program, the question is, working with Maven. So we have creating a Maven project, understanding the POM file and dependency management and plugins. So firstly, let me tell you the introduction to Maven. We have seen it is the build automation tool, right? Primarily used for Java project. And then we have also seen, I have also told you there is a remote repository called as Maven Central through which the dependencies will be managed. Then the build cycles, right? Clear build cycles are there here. That is compiling, testing, packaging, whatever we are doing. There is a clear build life cycle for that. And then it will allow us to integrate various plugins also, such as for example, say testing or reporting. So now we come to something called as basic of POM files, right? So whenever we go with the POM file, right, the POM file consists of the group ID, artifact ID, the version that we are using, the packaging, and the name of the project that we are creating, right? And the dependency file will again contain the group ID, artifact ID, what version we are using. The same thing, but say what type of versions we can say, JUnit or J Jupyter, so whatever it is, okay. So here we will be using only JUnit as our group ID and artifact ID both, right? So then the question is, the next one in that is how do we build it? So now let us start with that. Firstly, I will take it as an MVN because we are building a Maven project, right? So archetype. So what is the archetype that we are using? Followed by generate is hyphen D. So we have to specify, I told you, group ID. So group ID. Then, so what is the group ID? Group ID is nothing but it is the ID of our project. So usually it will be the domain or organization. Okay. So I'll be writing it as com.example. Fine. So this will be my group ID. Then I will go with the another thing ID I have told is the artifact ID, right? So I'll be taking the artifact ID. So what is an artifact ID? It is the name of our project, right? Pardon, it is hyphen. Okay. So artifact ID is the name of our project. So what is the name of our project? Say let us take it is an hello world. Okay. This will be the name of the project. So name of the project can change. Then we have the archetype artifact ID. So what is this darchetype artifact ID? So there is something called as Maven archetype quick start. So we use this for quick start template. So what is a quick start template? We don't have to write a Java project by our own. Instead, a simple Java project will be given to us. So that is why we will be writing on darchetype artifact ID as Maven hyphen, right? So archetype. So what is my archetype? It should be quick start because we are using a quick start mode. Say suppose if you don't want a quick start mode, you can remove this darchetype artifact ID. At that point of time, you will have to write the Java code by yourself. Okay. So next is de-interactive mode. So what is this interactive mode? Interactive mode is nothing but it will either keep the interactive prompts during the project or it will remove the interactive prompt during the project creation. So I do not need the interactive prompt. Hence, I will be keeping it as false. Okay. So let us just run this code and see. Be able to generate. Yes. So the build is successful. You can see it has been finished and we have to just observe that build success has been mentioned. So once this is done, we will be going to navigate through the project directory. So I told you what was our name of the project. Name of the project was Hello World. So if we have to go to Hello World, what do we do? CD followed by name of the project. So say Hello World, right? So once we do that, so we are into the hello world file. So this hello world file will consist of, always remember, the POM .xml file followed by source main java com example and the file name, that is app.java, as I've shown you while telling what were the contents that we have in the Maven, right? So POM file is nothing but the descriptor file that we are using, where dependencies and configurations will be defined. And then source main java com example app.java, this entire path, right? This will contain the Java main class, that is that will print whatever we required. As of now we have given a quick start mode, so obviously we will be getting the print statement, that is hello world or something like that. Okay, so once this is done, we are into our Maven file, that is hello world. So we will be going with build package. So say because I'll be creating a Gradle file also, right? I would like to rename whatever is there in the Maven. Okay, so let me rename it. Say my file name is hello world. So you can see I double click on hello world and I will find two things here. One is the POM file and another is the source. So I've told you there is a path. So if I open source, I will get main. Within main, there is a Java com. So why are we doing this? Followed by example to find the app.java file. So this is our Java file. So see, in the quick start mode, we get a simple Java program. So instead of hello world, I will just put it as hello Maven. Okay, changing it for the sake of Maven and Gradle. So I'm just closing it off. If you don't want, you can keep it as it is. Once this is done, now what is our work? We have to build the project with the Maven. So to build the project with Maven, we need mvn maven followed by package. So this will run our package. So this will run within our file called as hello world. So the build is again successful. So once this is done, we will go with running the project. Java followed by cp target followed by name of the project, that is hello world, right, hyphen. So what is the version that we are using? This will be always mentioned in the POM file. So you can see it is 1.0 snapshot. Yes, so I've taken it as snapshot. So it is a jar file, so dependency file, followed by what was our domain name, that is com.example, followed by the package name, that is app, right? So let me try to run this. See here, we can see we have got the output as hello Maven. So this is how we run a simple Maven program, right? So this will be the first part of running the Maven program. So if you want to clear the project, you can run mvn clean, and you can, if you want to clean up the build artifacts, whatever is done, right? So you can run mvn clean and it will all be gone. Okay, so this is the second program of our VTU syllabus, which says working with Maven, creating a Maven project, understanding the POM file, dependency management and plugins. So as I've told you, we have within the POM file, we will be having the group ID, artifact ID, the packaging and the version. So this version and the version that we are trying to run here, right, we are always taking it from the POM file only. So please check your POM file, it will mostly be same. So POM file will have this 1.0 snapshot, right? If it is any other, you have to change it here, that's the only difference. And if you go to the dependency file, you will have the group ID, artifact ID and the version that we are using. During installation we have seen it. So this is the second program, right? Now the question in the first program, second program was that how dependency management is done with Maven. Okay, so this is the question. So dependency can be managed in three ways. One is automatic download, so another is the transitive dependencies, and third is the version control. So whenever we talk about automatic download, so when particularly if you want to specify a dependency, right, so you will write something called as dependencies, and within that section you will write whatever you want. So whatever dependencies you want to pull it, right, that will be automatically downloaded from the remote repository. So I've told you the remote repository that we are using is Maven Central. So from there, whatever dependencies are required, you can pull it. right? Transitive dependencies means that Maven will also resolve dependencies required by other dependencies. So one dependency may have multiple dependencies, so we don't have to specify all those things. So dependency management with Maven will be done that you write one dependency name, whatever dependencies are on that particular dependency, right, that will also be automatically downloaded through Maven Central, right? So that is how dependency management will be done. The third one is version control. You can specify precise version for each dependencies, like so that we can ensure consistencies across the builds. Okay, so for that way we can use version control. We have program on this also, right? So I have told you about the three elements in this. One is group id, one is artifact id, and how we write those one dot snapshot, right? That is the version, right? So these are the thing. Moving on to the, I have also shown you the project structure. How does the project structure look? So these are the important aspect in the second program. So if we teach these part, that is more than enough. Moving on to the third program. So third program is working with Gradle. So how do we run the project with Gradle? So that is setting up a Gradle project and understanding the build scripts. That is Groovy. I told you we will be using the domain specific language such as Groovy and Kotlin, right? And the dependency management for working with Gradle and the task automation. So these are the things. So let me move on to the Gradle. So we all know that Gradle is nothing but a build automation tool, which is designed for highly flexible and fast and scalable automations, right? So it is widely used in Java projects. It will be also used in Android development and multi-language projects, right? So how can we say that Gradle stands out from the Maven? That is the flexible build script, as Gradle will be using domain specific languages such as Groovy and Kotlin, right? So in that way, so this will provide the dynamic and expressive way to define the build logic, right? So compared to the XML configuration, so we are using pom.xml file, right? Rather than that, this domain specific languages such as Groovy and Kotlin will work better. So hence Gradle will stand out in the flexible build scripts, right? Then if we go on to the incremental builds, whenever there is an incremental build, mostly everyone goes for Gradle. So why? Because Gradle will optimize the build time. That is the important point to be noted down here. So it will optimize the build time by determining what parts have been changed in the project, and only it will rebuild those parts, right? So that is the second point about the Gradle standing out from Maven. And the third point is the task automation. So everything in Gradle is treated as tasks, hence allowing us to create the custom tasks or use the existing ones is very easier in this, such as compiling the code, running the test, or packaging, right? So this is how the Gradle will stand out. Now if we have to run the Gradle project, right? So either either if you are running on the same, either if you are running on the same terminal, right? Make sure that you come out of that project. So I'll be using only the, because you cannot create within the file. You can do that, but it is very difficult for you to then search for that particular file, right? So let us do here. So let me take the first point, that is how to create, right? So I will create a directory. How to create a directory? Mkdir followed by, let me name it as hello world Gradle. So this will be my file name. So mkdir followed by hello world Gradle, right? So this will be the first point. So when I create this directory, then I have to navigate to that project directory. How to navigate? For using cd hello world Gradle. So we are navigating within the Gradle. Then we can say, now what do we have to do? We have to initialize. So in Maven we have run mvn. So in Gradle we will use Gradle followed by init, yeah, followed by type Java application. Yes. So this is how we run the, or we initialize the Gradle project. So once we initialize this Gradle project, so it will take some time to build. So now when the Gradle has started, it will ask us which type of script we have to use, whether we want Kotlin or Groovy. So let us take Kotlin, right? So then the second option will be what type of framework we need. So I told you either you can take JUnit 4 or JUnit Jupyter. So we will go with Jupyter, that is 4, JUnit Jupyter. So we will, because that is the default that we will be using. Then the name of the project. So I told you CD, that whatever we have used, hello world followed by Gradle is the name of the project. So once I do this, it will ask me for the source package. So all these details will be given in the default. So they need not worry about searching what will be the source package. Instead, whatever default is there, we can use it, right? So it is hello world Gradle. Once this is done, it will ask the target version of Java. So the target version of Java is 17, and so it will ask us to generate build using new APIs and behavior. We do not need that. So I'll just keep it as no, because this is the just simple program that we are trying to build in Gradle. So you can see the build is successful. So now once the build is successful, our next target will be to compile, right? So how do we do that? That is Gradle followed by build. So once we do Gradle build, the build will be taking place. So if you see here, the build is successful. So once that is done, we have to run the Gradle project now. So how to run the Gradle project? So Gradle followed by run. So once you click on this, you will get it as hello world, right? Because if you see in the Gradle file, I can show you. So you see the file name was hello world Gradle. So within this, if we go to app, source, main, Java, hello world Gradle. So if you go, this is the code that you can see. See, because we have generated the code using the DS domain specific language as Kotlin. So you can see this is how they write it. So package is there, followed by public class, whatever app we are using, returning. So if you want, you can change it here as hello Gradle, and then you can save it and just rerun the code and show it to students, saying that Gradle build. And so always remember, whenever you make a code change, always build it and run it. So you see here, we get the output as hello Gradle, right? So this is how we build the Gradle project, right? I hope this is easier to understand. So even within the Gradle file, right, we have some of the project structure for even that. So we have something called as build.gradle. Then we have setting.gradle. Within that we have source, main, Java. What that is what I have opened and shown it to you. So there will be an app.java at the end, wherein our code will be saved, right? So yes. So now within the build.gradle that I've told you, there are some explanations for these components of why these components are present in the Gradle and not in the Maven. So moving on to build.gradle, right? So this is the main build script in written in Groovy. Okay. So or Kotlin. Now we have chosen Kotlin. So build.gradle will be written in Kotlin. So what does this build.gradle holds? It will hold the plugins and the repositories or dependencies and tasks. All these things will be within the build.gradle. That is, the first thing is plugins, repositories, dependencies, and all the tasks. Moving on to setting.gradle, we will have a small script that will define the project name. And in this multi-project build, there will be some sub projects also, right? All these projects will be there in the setting.gradle. Now say suppose someone has built the application and you want to check what are the projects that person has built. So you can go to settings.gradle and you can find the project name. Under that you will find all the project builds that they have done, that is including the sub projects. You can find everything that is within the settings.gradle, right? Then comes something called as Gradle W, or we also say it as Gradle W.bat file. So it is a wrapper script, we can say. So if you open the Gradle, file, you will directly find something called as wrapper. So wrapper script, why are we using that? They will allow us to run the Gradle without requiring the separate installation on every machine, right? Separate installation on every machine will be required if we are not using the Gradle w.bat file. Hence, that can be used for automatically downloading the current Gradle version. Then moving on to source.main.java, that is where our source code is. I have shown you, right? So if we go to our Gradle file, yeah, so I can see the hello world Gradle was our Gradle file, right? If I go here within app, see, I can find here Gradle w.bat, right? So this is nothing but a wrapper script. And why are we using it? They will allow us to run the code without requiring installation on all the machine. And if we want to go to source main Java, right, we can directly go to app, and you can see the source here. We double click on source, followed by main, followed by Java, and the name of the project was Hello World Gradle, hence Hello World and Gradle. Within that, you can see app.java, right? So this is how we can find our source code. Then if we go to source test Java, there are some of the unit tests that we are using. Okay, so these are the things that will be seen in the Gradle. And the question will be like how dependency management is looked into Gradle, right? Or how exactly dependency management works in Gradle, right? So we have something called as repositories. So Gradle downloads entire dependencies from that defined repository. So what is the repository? Obviously Maven Gradle is the repositories that we are going to use. Hence all the dependencies will be downloaded from the repository. Hence that is the first thing how it will work. And then there is something called as dependency notation. So dependencies are defined in those simple format. Now if I say I wrote group colon artifact colon version, right, to know the version, so within colon you can write and you can get any data. So dependency notation is very easier here. Hence dependency management in Gradle is easier to know, and this will work in a way you have to put the group ID colon followed by artifact ID colon and version. All this can be taken out from the dependency file also with the POM file, right? Then there are some configurations types. So Gradle provides various configurations, right? Such as you can only compile. Now if I don't want to run and only compile, so there is something called as compile only, right? At that point of time this configuration type will help us only to compile, right? Then there is something called as runtime only. Then there is something called as test implementation, right? All these will be managed with the scope of each dependencies. Okay, so this is how we can say that dependency management in Gradle works. Then if we have to talk about the task automation in Gradle, right? So in Gradle, what I told you, whatever we are considering, everything is a task, right? Tasks represents the individual units of work, that is compiling code and running tests and packaging application. So Gradle comes with many of these built-in tasks. So that is again provided by plugins, and it will allow you to define your own custom tasks. So in this way, task automation will be done. So now if we have to look into the built-in tasks, right? So some of the built-in tasks that Gradle gives us is the compile Java, which will help us to compile the source code in that particular path, that is source main Java. Then test can be the built-in task because it will run the test in that source test Java. Then we can take a built-in task as jar because packages compiled code into the jar file, right? We need it in the jar format. Hence jar is also a built-in task. Then we have something called as run. So it will run the application, and if the application plugin is applied, then it can run. Okay, so that comes under the built-in tasks. Fine. So this is how our entire program works. So we have covered 3 programs today. So first one is the installation, firstly basics, and then entire installation of Gradle and Maven. For that we have used JDK. Then we have worked with the Maven, how and project can be created with the Maven. Again, if you don't want to start with the quick start mode, you can just remove it and go to that particular file and create your own file. So I can just show you here. So whenever, if you do not want to create the file, right, say you don't want a quick start mode, so whenever you go to this source main, right, just go to Java, there will be hello world will be there. in this Gradle, right, you will have a blank file. There will be nothing here. You can just create an Java file here. Okay, in that way you can skip the quick start version. So quick start is better to use because even though you have the code in that, right, you can just alter whatever codes are required. Fine. Then we also saw how a Gradle project is created. So in Gradle we have seen how in particularly in Maven we have seen how these group IDs, so without group IDs and artifact IDs and the interactive mode, right, we cannot create the project itself. So while creating the project we should make sure that we know our group IDs, right? So this group ID will be always com.example. Make sure that artifact ID is correctly defined, that is the name of your project. Okay, so those are the contents in Maven. And we have also seen the program structure for Maven. Then we are checking for the Gradle now, how Gradle works in the same way as that of Maven. So we have set up the Gradle project and we have seen how Groovy can be used to create a file, that is domain specific language called Groovy. So we can also use Kotlin. It is very slightly differing. You can try it and see. So once we do that, we will create a file, and then we will move into navigate into that file and initialize the Gradle using Gradle init. And then we can check the program structure. If you want to make any changes, you can give it to that. Else you can directly run the code, that is build and run, Gradle build followed by Gradle run. Fine. So in this way we can complete these three programs. So moving on to the next program that will be done tomorrow. So I just want some time to run that because it will take slightly longer time. We can do that tomorrow. So if there are any questions to be asked, you can please ask it now.